Okay, okay. Let me pick the slides.
Oh, you haven't uploaded the slide yet?
Already. Just need to
Oh, okay,
change.
okay,
Okay.
okay.
Can you see the slide?
Yeah.
Okay, that's good. Okay. Thank you, Isaac. Hello, everyone, and good afternoon. Uh, my name is Kamal Mustafa, and I'll be presenting the topic of exploring open source task queue and implementing one using PostgreSQL and Python. So, before before I start, allow me to introduce myself first. This is actually my first time speaking at GNOME-Asia Summit, and in fact, my first time joining this event. And maybe a little confession, if I can. I'm not using GNOME anymore actually for the past few months. I'm just giving KDE Plasma a try and then stick with it until now. So thank you to the organizer for giving me the opportunity to speak at this event, and also thank you to Sazuan for actually suggesting me that I submit this talk proposal. So I am professional web developer, currently as CTO at the local labs, where we built an OTP one-time password API named GetOTP, and it's allow you to add all OTP features to your application without having to implement all the OTP flow and UI. And while at Oxo, we built a telephony API, which consists of API to send and receive SMS, make and receive phone calls, and some other stuff. So we are fully remote company starting since 2007, and myself have been working remotely since 2010. Yeah, so this is a photo of us, which I think was taken in 2019, where we have our annual team camp in Okinawa. The place is Shuri Castle, which is unfortunately not long after this visit, it was burned in fire. I think in October 2000. No, in 2019. I think. This is also our last team camp before the pandemic kicking in last year. Okay, so back to the topic. Let us first see what's in this talk. Okay, we'll look first into what is a task queue, why we want to use task queue, example use case, a brief overview of the some common open source task queue, why using PostgreSQL to implement the task queue based on our experience, and finally we can go into some questions. Yeah, and so before I get into what is task queue, I think another important question is why I picked this topic of task queue for this presentation. The topic is very close to me as it is one of the first problem we have to solve at Zoxo back then. Back in 2010, we launched our first services called Easy SMS, where one of the features was to allow users to send SMS to up to 1,000 recipients, either by entering the recipient list in the web form or by uploading a CSV files containing the recipients list. So in the initial version, we did it in naive way by processing that directly, where user upload the file. It's not taking too long before we realize that it's not going to work. So sending SMS is a slow process already, and on top of that, we have to do a lot of things like making sure that user has enough credits, and then do some routing decisions on where and how to send the SMS. So it takes a very long time, and very often the request will get time out, and the whole process will break half the way. So we realize we have to store the task in queue first and processing it later on. So this was when we built our first task queue implementation using MySQL. But I'm not going into the details those, as today's topic is about Postgres instead. So What is task queue? So if we Google for the definition, we can see a number of them, but in a simple words, it's just a way to store a list of tasks to be done and execute later. The same concept also exists at OS level. Linux process scheduler also use queue to keep track of process to run. But we are not going to talk about that today. Instead, we want to look at much higher level in web application on how the same queue concept being used. So this is a simple diagram showing the queue concept. So we have the producer who will add tasks into queue, and then a number of workers that will pick the task from the queue and execute it. It's a simple concept, and we can also see this even in real life, at the post office, supermarket, etc. So in the context of queue, I'll be talking here mostly the one that will be mostly being used in web application. The nature of web application is that they are driven by a usage model that is called a request response workflow. When you type google.com in your browser address bar, you are basically making a request to google.com to show you something. In return, google.com will return you a page, and this is the response. You click a link, type a search keyword, and click search button. That's another request, which will return another response. The process repeats indefinitely until you think it's enough for the day and it's time to take a break from the computer. So the problem with this request response model is that there is a limit on the amount of time user can wait to see the response. Searching for keyword might be fast. It's indeed fast, as what generating the billion for Google. But what about uploading 1 hour top video to YouTube? That might take some time, as other than just saving the video file, there might be some other process you need to do as well to the video. The typical workflow is that after user done uploading the video, you will show a message showing that the video is now being processed, and we will let you know when it's done. So this is an example of queue usage. So, and in other contexts such as system with multiple servers, which is very common nowadays, you might want to do the processing at some other server, not the server which are originally receiving the request. So you need a way to dispatch the task to other server. The third reason why you want to use a task queue is to give you some architectural flexibility. What this means that there is no need for the producer to use the same technology stack as the workers. As shown in the diagram here, the web application that serving the request might be a PHP application, but to process the task, maybe using Python or Go is more suitable. So you can achieve this by using the task queue, as long as the task data is stored in a way that accessible to all those languages. There is no limitation that tasks produced by PHP application can only be processed by PHP workers only. Right. But let's look at some example use case to use for using task queue. We have covered one before, which is uploading video, which is processing video after upload. Other is like sending email, generating backup, or even replacing a cron job. Most task queue implementation today also include a task scheduler that allow you to specify what time that particular task must be executed. So while preparing for this talk, I received an email from organizer to test the video conferencing platform that they will use, which is Big Blue Button, the one that we are using right now. And the interface that we are using now, on the other hand, is coming from another project called Greenlight. So I'm just curious if I can see some task queue usage there. So I picked through the source code, and it's indeed some usage there. You can see in the in the screenshot, here it passing some tasks to the task queue to notify user when the room is ready. And here they are using rescue, which is one of the task queue library in Ruby. And let's see here. So yeah, okay, how it's been. Okay, so other than rescue, what else open source task queue libraries available out there? So it's very long list actually. So here I just list some that I kind of familiar with. So first here we have Celery, which was written as a task queue implementation for Django, but now has grown out to be a generic task queue for any Python project or even non-Python project actually. Instagram, probably one of the high-profile Celery user based on based on the talk of their engineer at PyCon 2013. Django queue is the task queue that we use at Zoxo. We are still using it in some parts, although for the core messages sending, we are using our own implementation now with Postgres. GNOME is one of the oldest task queue implementation that I know. I think back in around 2005 for use at LiveJournal. Not sure if any of you still remember LiveJournal, but it's one of popular blogging platform back in early 2000. Down at the bottom is Oban, which is implemented in LZ. I know Oban very recently. Actually, a friend of mine is using Oban in one of his projects. What interesting is that Oban also using Postgres, which is very related to this talk today. I don't know Elizabeth, so I can't say much about their implementation. But a cursory look at their code, I found the basic design seems not much different than ours. Okay, when talking about task queue, another important component in the task queue is called a broker. So message broker is also known as or integration broker, or is an intermediary computer program. Okay, that's the boring definition, but basically what the broker does is it serves as a intermediaries between the producer and the consumer. So the producer will push the message or task to the broker, and the consumers will try to get a new task from the broker. Okay, so there's a number of brokers that you will see if you look into this, or there's a couple of protocol that commonly used by the broker. So either they will be using the common HTTP, or they will use the more what I call it specific protocol for queuing implementation, which is AMQP, Advanced Messaging Queue Protocol, and also there's also MQTT that more commonly used in IoT fields. Okay, and then there is a couple of broker implementation. You can see here there is a RabbitMQ, ActiveMQ, which is this is basically an implementation of the AMQP protocol. RabbitMQ implement the older version of the AMQP protocol 0.0.9-1, while Qpid and ActiveMQ implement the AMQP 1.0 specifications. And then we have the cloud offering from AWS named SQS. There is also ZeroMQ, and Redis actually is not a broker. Actually, it's a key value store database, but some of the features that Redis have make it suitable to be used as a task queue broker. And of course, finally, we have PostgreSQL, which is basically the topic of this talk. So, so why using PostgreSQL as broker? We are using SQS actually before implementing our task queue with Postgres. One pain point is that inspecting what's in the queue, SQS doesn't provide a specific API for that. To inspect tasks in queue, we have to pull it out using the same API as the worker, which means we have to compete with the workers. So we have to try a few times before we manage to get the job, or else we have to stop all the workers, which is not practical or ideal at all. And another reason, I think the main reason we decided to implement our own task queue with Postgres is because we need the multi-tenant support, which is very crucial in our use case. So as mentioned before, we use SQS before we move to Postgres. So one of the main problem we have at that time is that to ensure each user task is being processed in a fairly manner. For example, if user A add 1,000 tasks and user B add 1 task at the same time, so we have to make sure that the task for user B should be processed immediately instead of waiting for A to finish, which doesn't make sense, right? A has 1,000. We only need to do 1 task, and they have to wait for that 1,000 tasks to finish first before their task will be executed. So that's not acceptable at all. But this is hard to do in SQS, as we don't know which task each worker will get. We can create a separate queue for each user, but this will add more maintenance work to provision the queue for each new user and then delete it when the user is no longer with us. So we searched around until we found this blog post from holic6.io. So the mechanism explained in the blog post looks simple enough, so we give it a try. Right. So there is a few how to call it, a couple of features used for task queue, which is true. But there's a couple of things or reasons why we still want to use database SQ. For example, it's allow us to use common tools. For example, like I mentioned just now, in order to inspect the database, for example, we don't need a separate API. We can just use SQL, just select all from the tables, and then we can see what is the task in the queue, right, based on the status and everything. So you can just use common tools to do that. And one of the reason why people say that it's not advised to use database RDBMS for implemented task queue is that certain things such as a locking issue, which is very tricky to implement if you want to implement a task queue. So when you are fetching the task from the database, so we want to lock the record, right, while you are doing something or while trying to update the status, everything. So that to prevent more than one worker to actually fetch the same task and allow a duplicate processing of the task. The problem is that if you lock the record, the other worker that trying to get a new task, they will have to wait until the log is released. So this means that you won't achieve the concurrency here, because even though you have more than one workers, 2, 3, or even 10 workers, which can actually process the task at the same time, but because of the log, all those 10 workers has to fetch the task serially, right? So it means that it doesn't, even though you have 10, it's like you're executing that just one workers one by one, which is not practical when you have a lot of tasks to be processed. But in a recent version of Postgres, they added this one features which they call it the skip log, where when you are doing the query, you can tell PostgreSQL that if the rows that they found is logged, don't wait for the log to be released. Instead, just skip it and then move it to the next row. So this is what actually allow implementing task queue using PostgreSQL is much easier compared to before we have this skip log features, which is still doable, but it's a bit tricky, maybe. Yeah, and another features that Postgres has, we call it the listen and notify, which is allow you to make a connection to Postgres and just say that you want to listen on certain channel, right? And then if you want to add tasks to the queue, you can just insert a row and then notify that channel, and then that notification will be sent to all I can say workers that actually listen on that particular channel. So that also helped in implementing task queue. However, we are not using that approach. I think Oban is using the approach, using the listen and notify. In our case, we just using the polling method, which means that we just have a loop that keep checking the database all the time, looking for the next job. And to implement that, we just implement that in Python. So we have a Python, and then we use a library called Pebble, which is a library on top of the multi-processing modules that allow us to run Python function in the multi-processing concurrently, right? And then we use supervisor D, which is also another Python libraries to keep the workers running. Okay, so yeah, I think that's all about some of our experience in implementing the task queue in using PostgreSQL and Python. So I try not to go into more details here, because I'm not sure if the audience here is a developer or non-developer, so the details might be means a little bit boring. So, but I already submitted the proposal, and it's already accepted to go into details on the implementing this task queues in Python at PyCon Indonesia, which is will be held next month. It's also will be done also online. So if you're interested to know in details on how to actually implement the task queue using Python and PostgreSQL, feel free to join PyCon Indonesia next week. So yeah, I think that's all. And maybe if anyone have questions, then we can discuss a bit about this topic.
Okay,
So I
thank you,
think,
Mr. Kamal.
yeah.
But I think you're aware, right? Your slot is until, but yeah, but it's okay. But we have a question here. What is the difference between message queue and task queue?
Hold on, I'm opening the. Oh yeah, I think the difference is just in the name.
Oh,
So,
so
so people, so the term being used, so some people use message queue, some using the task queue, some using job queue. If you go into the details, there might be some subtle difference, but overall, I don't see much difference other than different terms that people use, and also maybe the usage. So message queue, maybe they will use more when the domain that where you implement the task queue is like something that's involve messaging, right? So involve messaging. So for example, you have an application that you need to notify multiple users. Then in order, so you use task queue in order to disperse the message, right? So you call it message queue, right? So that's because what you are doing is that you are adding a message to task queue, and then for you to disperse the message. So that's task queue. That's message queue. But maybe you have something that need to do something, which is a task, right? Need to do something. So what you call what being added to the queue is task. So it's becoming a task queue, right? The common implementation so far, even at least what being implemented in a number of Python libraries that I have used, or like I mentioned previously, the Celery or Django Q, or I think there's a couple more. But the common way to implement that is that you just what you put in the task queue, what you consider is a task is just a function name, right? So you put the function name into the queue and couple with the arguments that you want to pass to the function, and then when the worker fetch the task, so it figure out what's in the function. It will try to load the functions, right? It try to load the function, and then it will try to call the function with the argument specified in the task. So that's considered the task. So that's one of the common implementation. This is basically when the queue is a generic queue implementation, like Celery, like Django queue. But there might be where if you are implementing this queue yourself, right? So you might be implementing this for very specific use case, So then the semantic of how you are referring to the task might be different. It depends on how you want to implement that. Using function name as the way to a semantic to describe the task is very generic. So by using the function name, you don't have to, means that it can be anything, right? The function can do anything, right? It doesn't tie to a particular use case. It can be for sending email, it can be for generating thumbnails, it can be for processing videos. It doesn't matter, right? The task queue libraries itself, that it doesn't have to know what the workers will do with the task. All it needs to do is to just make sure that the task is properly saved in the queue, and then being distributed to the workers, and then if required, make sure that the workers finish the task and update back the status to the broker. So that's all I need. What's the the worker is doing is not the broker's concern. But if you are implementing the task queue yourself, right, you might be implemented for a very specific use case, right? For example, you just implement this task queue just for sending email. So maybe when you are serving the task, you just call it the task name, maybe you call it send email, for example. So that's the semantic that you define. But the problem with this is that later on you might realize that other than sending email, you also want to do other things that require the same kind of processing. Maybe you want to now previously you want to just to send email. Now you have a new requirements. You want to generate a thumbnail when you upload your photos, for example, which means that you can't directly use the previous implementation, which you call send email, because that is just for sending email, right? So then you have to do some refactoring. Otherwise, if you implement that generically, which means that the unit of task is just a function name, then as I said before, means that doesn't matter what requirements comes in, you don't have to make any changes to your implementation, because what you need to do is just pass the function name to the queue, and then it's up to the workers on how to call the function and how to execute the function. Yeah, that's it.
Okay, thank you, Mr. Kamal. Since since you still have ample time, is it possible that you show a short demo, or is it possible? Because you still have like 20 minutes, but I'm just asking, is it possible to share with us some short demos about the task queues?
I'm not preparing the demos.
Okay, sorry. Any samples or just now that you can share? Like earlier, you see the codes of the big blue button, right? The green light, and
Yeah.
some of your not so any sample other codes that
Let's look at one of the blog posts I mentioned. I think I don't go into details on that. So
you have some blog post that you can share your screen.
Let me open that first. Okay, then I need to share this screen. We share it. Screen. Back to. Okay. Allow. Can you see it? Can you see
Yes, can see.
Okay. Great.
Yes.
Okay. Oops. Okay. Okay. So when we have problem with the SQS before, so we search around on how to solve to make sure that we have the multi tenant support for the task queue, to make sure that, so we have problem, one user is sending maybe 2,000, 10,000 of messages, and then they are clogging the queues, and then we have another users which is small user, maybe they're just sending 10, 20 message, but now they have to wait for these users that sending 10,000 to finish, which doesn't make sense, right? So we search around and then try a couple of things, and then we found this when you search for multi-tenant support in Salary, for example, there is a various solution, but we found it to be quite complex, or it added some maintenance overhead, right? And we found this. We go through this, and then it seems that it's quite simple. It's easy for us to understand. I think this is very, very important, right? If you can understand the things on the first sight, then it's a sign of good things, right? Because you can understand it. Because I try to avoid going to the solution that maybe kind of work for us, but we don't really understand. So it means that just waiting for a problem later on. So going through this, it seems easy to understand. So, for example, here you just has one table called jobs, which is very simple, and you saw like the job ID, the job name. Here I look at source method. So source method is what I refer as the function name, right? So this is where you store the function name, what to execute. Here's the arguments to the function, and then the job status, and the rest is just for start time, end time, right? It's for timekeeping. And for the status, we also use something similar to this. So we have queue, running, success, error, we're using fail, but doesn't really significance. So it's very simple. And then we okay, this is the key that actually allow for the multi-tenant supports, which just a table to say that okay, this user how many slots here means that how many workers they can have running at the same time. So for example 3 10 depends on the capacity that you want to allow to the user. And then you just have this query to actually fetch the job to be performed. And it's also quite easy to understand. This is actually using what they call it the CTE, common table expression, which is allow you to specify what I call it the views on the fly, so you don't have to specify the views beforehand, so you can just do it in just a single SQL statement.
Sorry, this one is SQL for Postgres, is it? The one that you show here is specifically for Postgres. Okay.
Yeah, it's for Postgres. But actually, nothing here actually specific to Postgres. I think this is very standard SQL, which means that it also will work in MySQL. MySQL 8 at least. I'm not sure about MySQL 7. Yeah, because I think MySQL 7 doesn't have CTE. I think. So yeah, so then you define this is where you make sure that user is limited to the number of slots that they have, so that they don't exceed the if they already have 3 tasks running and then their slots maximum slot is just 3, then we don't exclude them in the result, right? And then this just this.
Okay.
And
maybe I missed your slide about just now. So that's compared to either Maria, why specifically you use Postgres? I mean, it's like, does MariaDB also got these features that can be used, or what, or how, or why?
Okay, so I'm not sure. I can't remember exactly. At that time, we are working on this whether skip log has been added or not. I think skip log has not been added yet to any of the MySQL implementation at that time. So skip log is, I think, it's quite recent actually. I'm not sure which version. So it's quite, so that's I think one of the main reason. Another reason is that I feel more what we call it confident with Postgres. Having using we actually using MySQL for all other parts in the application, but I also started with Postgres, and then I think that for this particular implementation, and given that I have seen a couple of other implementation as well using Postgres as the task queue. For example, the listen notify features that Postgres has, that's none of other database has that. So I think there is more room to grow if going with Postgres instead of MySQL.
Just now you mentioned the main the message queue, task queue, or job queue are the same, right? So it means does the job queue in MariaDB also can do this kind of sort of function for the task queue?
I'm not aware of that. They have what called job queue in MariaDB.
Job queue daemon plugin.
Okay.
I'm not sure. I'm just throwing questions lah. Maybe some things that can be decided. So because like MariaDB, what I noticed is they fork off MySQL and then they enhance. So I'm not sure if this similar to what you call the task queue.
Okay. This I haven't didn't found this actually when I was looking for a solution for this.
No
So
worries.
I can't say much.
Just,
But okay, here and then here you can see here the skip block they mentioned here. So this is I think in 2020. Yeah. So you can see that skip block also available now in MySQL. Yeah.
but the one you open is a Pacona, right? So is it like this the different one? So that's why
No, skip block in all version of MySQL
SQL.
they have skip
Oh,
block. At least
okay.
MySQL 8.
Oh, 8 and above. Okay.
Yeah, 8 and above. Yeah. Yeah, so yeah, that's it. So that's the basic of the SQL. So we
Okay.
just try this and then do some couple of quick demo, quick tests with multiple console at the same time running this SQL, and then it seems to work. So it's very simple. I think that okay, I think we can go with this. So we start implementing the Python code. So here is in Ruby. So the example here. So we implement that in Python, but actually it's not
Sorry,
not
about
much different.
earlier you're talking about the OTP. Your company doing the OTP, right? Is it like a normal OTP sending 2FA codes or what? What's the OTP for?
Yes, yes. So it's allow you to send one-time password, and the use case is up to you. For example, you might want to implement the TAC use case and implementation, right, in your application. So like on the Maybank, right, you want to send user verify the TAC before they can proceed with the transaction. For example, that one example use case. You can also use that also maybe for passwordless login, right? So user don't have to remember the password. So they enter their phone number and then we send the OTP to their phone. They verify that and then they can log in. Also another use case. So yeah.
The messaging gateway. So you also provide that service, or is you just application only? So the SMS gateway, we need to deploy ourselves to integrate
No,
with
no,
your
no, no,
application.
no, no. We handle that all the messaging we handle all that.
Oh,
So you
okay.
just call our API to say that you want to initiate OTP flow,
Okay.
and then we'll return you a URL for you to redirect your user so that they will see the OTP page.
Oh, okay.
Yep.
It's not through the normal SMS or something. It's through the web page. So you redirect it to the page, is it? The code.
Yes, yes. We handle.
Okay.
So you redirect the user to our page, then we handle that from there.
Okay. 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 Okay.
I
I
think it's
think.
similar to. Yeah, sorry.
Sorry. Go ahead.
No, I think it's just similar flow. For example, I think, for example, right now when you want to make a transaction using credit card, right?
Okay.
Before you can
Oh.
proceed, right, you will be redirected to a page, to other page where you have to.
Okay.
You
Okay.
will wait for the OTP to be sent, and you enter that, and then you will return back to the merchant page.
So you handle both of it. You send the code and then the redirect page as well. So it's similar to the
Yes,
credit card. Okay.
yes, yeah, similar flow.
Okay. I think that's all. So I think we finish up a bit earlier, earlier than 10 minutes. Okay. Thank you, Mr. Kamal. Thank you for your time and participate with us, GNOME-Asia Summit 2021, and hoping that you also will not stop here. Maybe you can submit your paper on GWADEC, and we also have another event. The bigger event for Genome is a GWADEC, so maybe you
Okay,
can try your luck
okay,
for the next GWADEC as well. So
okay,
thank you, Mr. Kamal. Thank you for having you here, and good evening. Thank you, everyone. Thank you.
okay.